Okay, so cybersecurity and data management. This is a complicated space, particularly on the security front. There's a lot of moving parts here, and there's a lot to kind of sort your head around. So I definitely I'm happy to kind of be here and to be able to at least provide a little guidance, and hopefully some of the things that I say will be of benefit to those that need. We're really just going to talk about those two areas as a basic goal. We just want to sort of outline any security points for a technological solution, and likewise on the data management side of this. We'll keep it very basic and high level. So, we're not necessarily going to drive too much into a bunch of hard details. It's sort of like a black hole. Once you kind of go down certain windows, you just can't come out. You just kind of stay right there because there's so much to talk about in any one of these areas. But hopefully we can field some questions that you have in those particular areas. But other than that, I think we'll just want to try to give you a broader view of what's kind of occurring within the cybersecurity space. These are sort of the three blocks that I really want to touch on. First, access. And access is a traditional. When you think of access, think about it from access points for a particular technological solution. Those access points could be laptop. It could be you could be on the office or network system, or you could be on your mobile. There's different types of access points. And so when I think of access, I think about it across some of the ways that we access our technological data. Security from the perspective of an application, I'm thinking, or most of what I'm sharing here will be within the context of a configuration. So that's a build of the application itself, and kind of how certain modules are secured versus others. And then on the data side, how data security works with respect to these individual applications or an overarching structure. Okay, in terms of application access can be fairly complicated nowadays. The basic parameter around application access is authentication, either single factor or multi-factor authentication. And this is sort of your basic passwords, or at least your basic password for the single factor. Multi-factor, they may have sort of that second. You remember a lot of the time, a lot of banks use this, where you may enter your password information, but then they'll require you to validate that with your cell phone, or have a security key around your cell phone, or some sort of a remote access key that you sort of have to enter in order to get into the system. And it's sort of a double layer, and you sort of have to do it every single time. There usually isn't a save space. That's usually what they're trying to get around, is a application that or a lot of the browsers that might save your username and password and into their browser settings, and a user who isn't necessarily you can then use it. So that's how the multi-factor kind of works. On the client side, an individual computer, if you will, can have access, right? It could be a company issued laptop, can have access to either a web-based application, or even if it's not, certain IPs are accepted and certain ones aren't. So if you're not trying to get into the system via approved clients, then they won't allow you to necessarily get into that particular system. The other common use on the security front is network security. So you can lock down the whole network. So you can only access a given application if you are on premise or within the overall network. And outside of that network, it's like a private kind of network where there's certain controls around that. Then you wouldn't necessarily be able to access the application or website even if you're not necessarily on site. Like if you're just at home, you can't access it, but once you get on site, you can. And then there's cloud access. Clouds are pretty, if you, depending upon how a given application or technological solution is sort of built, if it's built within a cloud structure, then you do have the parameters of a cloud. And this also applies to certain web-based systems. So if you think of a system that is totally designed and used in the cloud, it's completely 100% web-based, they are sort of automatically are subject to a lot of cloud-based cybersecurity controls. I think, though, one of the important parts of that sort of needs to sort of get mentioned as it relates to that is on-premise security is not necessarily safer than cloud-based security. I think that's a common misconception. It's been a misconception for years and years. I think maybe originally I think there was some validity to it. But at this point, there's not that much validity to it. And it's not to say that on-premise solutions aren't secure or that they can't be more secure than the cloud, because they certainly can. It's just the likelihood is low. And a lot of that has to do with the fact that a lot of cloud-based companies, I mean, they have teams that cybersecurity teams that is their job. That is the job of the team to secure the cloud. So you don't really hear about a ton of breaches. You hear about a breach every now and then, but there's probably people trying to attack cloud infrastructures or applications every day, and they're not particularly successful. So there's multiple levels on the cloud side where there's security, and so it just becomes a lot of layers for a given hacker to kind of come through. So as it relates to recommendations, I do want to make a note that, and this is, maybe it's just me having, dealt in this particular space and seen a lot of different sort of build outs. I do think it's important to note that you want to be careful with respect to security, and you don't want to necessarily create a poor user experience or a bunch of inefficiencies that develop in your organization because you're almost over secured. I know that sounds ridiculous, but in some cases I've seen it. And all of this is going to be subject to a lot of the parameters that organization has to work within. If you can imagine HIPAA, for example, if you have to deal with HIPAA laws, then you have certain security measures that you have to follow. Likewise, if you're maybe a public company or something like that. So there's no broad brush here as it relates to security. I think that there's some baselines that have to be factored in across every organization. And kind of when you're starting to work with an organization at this particular, you start to create or at least outline what some of those requirements are going to be, and you sort of attack them there, right? Particularly like a banking, they may have some different requirements than maybe a manufacturing company. But just in general, you do want to kind of think about how do you kind of create an environment where there is ease of use. I personally like to kind of think about it from a client access versus with maybe multi-factored if that's more desired, or sort of switching it if there's a lot of network access with quality security there, then having the security knowing that, okay, we can do more single factor authentication because you can really only access this when you're on the network to begin with. So there's ways to kind of make that easy rather than create an environment, for example, where you got multi-layer multi-factor authentication and you have network access authentication. It turns into a space where it's like we're securing at every single level, and it just creates a certain difficulty when trying to get access to an application. So that's application access. In terms of configuration access, every ERP system will have some form of configuration security, and I think the same point applies here with respect to being over secured, but I do kind of want to walk through a lot of these recommendations and kind of how configuration security kind of works, because an application will have a set of defined roles, And I think it's very, very important, particularly during an implementation, that that those administration roles are taken seriously. Everyone kind of wants to raise their hand, and say, "No, I'll be a super user, or I'll be one of the administrators." But then, the organization sort of starts to become dependent upon that particular role, and if they don't necessarily if they're not available for example, if you're one of the security administrators, and you have to provide access to a new user, if you're not available, or you don't really know how to do it, or really want to do it, then it sort of creates an issue within the overall organization. So usually administration is happening at every single module. There's usually some form of security administrator for every single module within an application, and then there's some form of security administrator for the overall application in general. And so it's important to sort of create what I'm calling the security metrics, where you have those user roles sort of outlined across your organization, sort of, and kind of fit that and review that and make sure that the right people are associated with that, and make sure that there's proper backup for a given role, so that you don't create a scenario where you have this application that needs an approval, and there's no one to approve, or that role has not necessarily been defined yet, or the person that's on approval is on vacation right now, or maybe they just left the organization and there's no one there for backup. It sort of creates this, again, inefficiency within a given process or within the organization that a lot of the times can sort of be handled through a well-defined security metrics. And the unfortunate part about it is a lot of those security metrics are done in Excel, so there's no real notification process when an individual leaves or when an individual is on vacation. But just the same, it's very, very important that you at least at a bare minimum know whose responsibility is what within the application or within a configuration, so that you can kind of go to that particular person, particularly when consultants are gone, when the consultants are no longer in the room, and you're responsible for the entire application. And this can be a problem. Okay, and then there's data security. I think data security is, I don't say it's often overlooked, but I lump into there some of the integration components. But you can have security at the database level, right? So you can have your application grade, you can access in it, but then the data itself maybe sits on a server, a SQL server, and there's security points there. You can also kind of have web service security points where there's password sort of authentication revolving around a given API. So what web service can call into that particular database to access data, that security point needs to be well defined as well. There's a certain amount of security that can be, this might be application specific, but can be around individual reports. Some applications sort of allow for that level of definition. Where you have a given report and only certain people can sort of see this report. Other organizations may put it within the context of a module. I'm sorry, other softwares may put it within the context of an overall module. You have access to the module, or you don't necessarily have access to a module or specific pieces of that particular module. But I'm talking specifically about a data report here and the use of that. Some organizations sort of have data points, access points around that. Data encryption here, as it relates to data, I think is a very important detail. Data encryption, and then data encrypting folders. So you can encrypt the data itself so that there's certain types of masking for the individual data fields within sort of a data set, right? Or you can also encrypt folders where that data lives. The encryption of folders is critical, certainly for implementation integrations. You kind of have to have that, and I think I note that a little bit later on. But the data encryption for specific data within a database is a level of sensitivity that I think should only sort of be reserved to certain types of data. And all of this for me kind of gets into the need to really outline where your sensitive data is, because there's certain data within your organization that you're legally bound to protect certain ways. Things like social security numbers, credit cards, et cetera, et cetera. A breach there could be on a different scale, particularly if it's customer related or something on that scale. So it's important to kind of go through all the data that your organization kind of has and sort of outline the buckets where sensitive data lives. It's not all the same, and it shouldn't all be treated the same way, and it shouldn't all live in the same place necessarily. I think we've gotten to a point where we can segment certain parts of our data and it not necessarily be a big thing with respect to your overarching architecture. So, outlining the data that must be protected, outlining the data that needs to be protected. So data such as financial data, right? You don't want profitability to necessarily be seen. If it does, it's not the end of the world, but you might want to guard against some of that particular data, or some of the salary, for example, data. You may want one person's salary, even the same level. You don't necessarily want everyone to see that, and so the data measures around these buckets of sensitivity can be slightly different, and that's not necessarily odd per se. I think it's very important to have a flexible strategy there, to outline those particular data sets and then sort of apply the necessary security measures as a result. So that's data security. Now I kind of want to touch a little bit around data management, and then we can kind of answer some questions here. For, I guess, overall data structure, I think it's important to define data management because a lot of people use it. I don't know, I hear it so many different ways. I think about it as the whole suite. I think about it as everything data related. I think about it as any policies, procedures, data structures, like everything is on the table as it relates to data management in my mind. I think as a practice, and I rarely see this, honestly, organizations that have a data dictionary, but there should be certain identification, understanding of the type of data that you have within your organization. Like what is it? Like what kind of data is it in your system? Is it data that lives? Is it role-based? Is it transactional? Is it analytical? What type of data is it? Is it structured? Is it unstructured? I mean, those are all pieces I think that mean something. And outlining that within an overarching dictionary, or really architecture that sort of has all the different data models outlined within your organization is a good thing. I don't think it's necessarily a favorite thing to do, particularly within the IT community. But this last point here that I have outlined, I think is a noteworthy one that a lot of organizations miss, and that is data is a very valuable asset. Organizations are making money around data. I mean, some organizations are built around reselling data, your data. Other organizations, data that they passively give to these organizations, and they then turn around and create marketing value out of those particular data points. I just say that to say that approach to data should be taken a little bit more seriously, I think, within organizations. And this is part of that piece, like understanding the data that you have, understanding the overall structures of the different data sets, being able to identify any holes in these particular sets from a governance perspective. So after you create sort of a process, end-to-end model, all the different data models that are there, and then kind of create this sort of process, a mapping that shows kind of how data flows across your organization, I think you'll start to maybe even identify where there's holes, especially as it relates to integration, and then creating sort of a regularly backed up schedule that's even absent of maybe you put it into your cloud environment, you kind of know where it is, just in case you have to kind of call that data later in the event that something happens. I think that's very, very important. I think those kind of strategies, I think, are critical within, I think, a well-functioning organization. And so, data should be securely backed up. There should be proper locations. A lot of that, should live within a cloud structure. There are usually ERP applications will provide some type of dynamic for that. One of the partners will provide some kind of service offering kind of around that. You should be able to just sort of do that natively through a basic kind of structure, even if you put a lot of those backup files into an encrypted folder or share folder that you sort of have. That works too, but understanding where it is, understanding what it is and how it lives, I think is very, very important. So that's a data structure. In terms of big data, once you get outside of the structure of it and you kind of get into the actual data sets, some organizations, not all organizations, live in a big data world. I think when you hear the term big data, a lot of the times it's really integrates a lot of the different data sets that are out there, because you can now today we have more access to different types of data that we can then sort of bring into our current data structures, and that sort of creates this dynamic where there's just a lot of data to sort of sift through. But individually, some organizations have huge data sets. Used to do a lot of work in the telecom space, and they would have these insanely large data files, if you can imagine, because they have so many customers, and the transactions for those customers would sort of extend over years. So you would have these streams of data. So as it relates to that, I think it does still kind of go back to architecture a little bit and kind of understanding first kind of where your data is, and then why that data is as big as it is. A lot of the times it's not so much based upon the basic parameters around we have so many customers, right? Like yes, that's a normal use case for having a large data sets. But a lot of the times it may be how the data is kept. It may be where the data is kept. Certain databases may create a larger sort of it made the storage requirements for those data sets, for those databases, may be larger than others. I really think of structured versus unstructured data. A lot of those structured data storage pieces are going to be larger. And as a result, I think you can potentially consider unstructured data if you kind of need to skinny some of that up. Why you would want to skinny some of that up is because sometimes big data can be a problem. Sometimes it can cause issues with respect to loading. So a lot of applications that are kind of slowly loading are oftentimes loading that way because the data set is too large. There's certain parameters around applications that sort of a RAM, for example, that sort of limit, or in memory, it might sort of limit how large a data set can sort of be brought into a space to be analyzed, and as a result, kind of you may need to skinny some of that data down. There are ways to do that without necessarily sort of removing your data, but there are ways to sort of skinny it down by just changing the structure from structured to unstructured, or having proper filtering so that we're really just calling the data that we absolutely need. But there's some strategy that you can incorporate within your overall design, and I think that strategy points back to what is the overall arching data architecture, and having a data architecture that allows for the need to bring in the kind of data that you need to bring in manageable ways. One way to the tools that are sort of used for this is ETL. For those that don't know what that is, that's extract, transform, and load. where you're extracting data from one place and you're transforming it. Maybe you're transforming it based upon a set of parameters. You might be filtering it down. You might be creating logic around that to sort of aggregate parts of that particular data that might skinny up some data. You might be creating calculations around some of those data sets to sort of produce sort of a certain result. And then you load that into the system that you want that system loaded to. Sometimes you're just putting it into a skinny, sometimes you're putting it into an encrypted folder for an application to sort of pick up. But it's sort of a more common tool that's used. Also APIs, it's not here, but an API is also a means for calling data from a different place. But in general, you have to sort of create sort of an environment where your data isn't necessarily as big as is lean. You want to create an environment where your data is lean versus unnecessarily big. And also you want to, if you have those backups stored, that's great. You want to delete as a result of that. Maybe if you have a backup and you have a policy that says we're going to delete files within the application because we have them backed up after a certain point, and we're going to decommission, after a further point. So you can kind of have strategies that sort of create a skinny or lean environment, and the skinnier the leaner the environment, the faster the overall application can kind of perform. So you do want to kind of think about all of those different components. But just to reiterate the point, big data can be a problem. It can create a lot of performance issues within an application and really bother the overall end user experience. But it also is a manageable one. So you can kind of create some ways to kind of work around any big data issues that you may be having if you deal with larger data sets. And lastly, here on the integration side, integration is, I think, one of the most critical parts of an organization's digital strategy. As great as the idea is that you have one system where all your data exists, where everyone lives in this one place and it does everything that we need it to do, the likelihood of having that is low, to be frank. Especially as your organization becomes more and more complicated. You have needs that sort of extend beyond the capacity of an ERP system that's working for you, and it doesn't necessarily mean we need to go buy another ERP system. It may mean that, but you may then just have a third-party tool that works in conjunction with your ERP system, and after that, at that point, you then have an integration issue to sort of manage. I think that you have to design a plan for your overall integrations, and it's important to understand that this should be based upon your data needs. Not necessarily. I mean, when people think about integrations, they kind of think about the tools but they don't necessarily treat integrations a lot of the times as sort of a separate requirement gathering sort of stage. A lot of the times, functional requirements are gathered, applications are sort of selected based upon that. Decisions are made on the functional side, and integration is sort of a back burner. But I can assure you, I've been on several implementations that have been delayed because the functional side is well down the line of doing the things that they need to do, and the integration part is lagging. Integration is a core part of all of this, and you kind of have to outline requirements for them separately. If those requirements extend beyond the application itself on the functional side, then you kind of need to have a plan for how you're going to integrate those particular data points. I think that those requirements can extend into issues such as, and we kind of talked about this in a separate session, I think that Kyler was kind of referencing, but batch data versus having real-time access to that particular data. Those are based upon your needs, again, not necessarily based upon what's cool or what's ideal. You may not necessarily need that data in real time, and if you don't, then there's no need to spend extra to try to create a customization or an API, a web service, if you will, that can do something like that. Some kind of batch may be just fine for that. So it should all be based upon your particular needs. Work within the structures of these ETL API kind of tools that are kind of out there. A lot of applications will have packaged APIs that they already are pre-configured to sort of manage against. Others may not, and they may have APIs that you sort of have to use through a tool, an ETL type of tool. Others may, other requirements may, call for an API to be custom. In that situation, I think you want to avoid that as much as possible. But there are situations where a custom API may be necessary to call particular data. But in either event, I think that's all requirement based. So it's very important that you outline what requirements you sort of have. The other part to integration is, and most people have this, but it's just important to note, is you're going to need a data encryption strategy. And a lot of that will revolve around folders, encrypted folders that are somewhere in your shared structure, where sort of data is going to sort of live. Having even a smart naming system for a lot of these folders, so that a particular folder only has it can only receive certain data files. Having a naming convention for the files that are produced in there. That convention could be based upon the name of the data that's sort of there. It can be a date it can be timestamp associated with that. It could be it could be a standard name. It could be a lot of integrations pick up a particular file name. So it could be a situation where you just name it, file, and the integration knows to pick up the file from this particular location, and the name of that pickup file is file, right? So you can do this a number of different ways, and I think there's a strategy around what makes the most sense for the overall organization when you're sort of outlining where files should be, and kind of what those names should be, and all the likes. And again, all of this for me comes back to the integration requirements and understanding what exactly are the needs of the organization for this particular data set. And once you kind of define those, I think the strategy and the other parts start to become simple. A lot of the times this effort doesn't necessarily get done until you kind of get into the middle of an implementation. And I think it can cause some delays as a result. You want to get on this as early as possible and start to share early in your implementation how you need your integrations to go, how you sort of need your data to sort of be managed. I think that makes the overall experience a little bit easier.